Okay, so to register for a course in Blackboard, you go to the front page, so I might click up here, and then you go to Browse Course Catalog, and then it's called Information Science. And I think you could put 2014 in it, and you go to Go, Information Science 2014, Go. Why doesn't it show it? Oh, you have to change it to, where is it? Here. App, and creation date. Why do they do that? That's crazy. Creation date before, yeah, Go. Now why doesn't it come in? Why doesn't it work? Contains, just try Information Science without the 2014. Let's see if that works. There. Information Science. I don't know why it has 2014 in it, but it doesn't work. Okay? So, now it's not. Did anybody register? You didn't register, right? Because it wasn't possible. Okay, let me go to it and set it. I have to go to here. Enrollment options. Allow student self-enrollment. Okay, try that again. We'll go here. Go to this here, Browse Course Catalog. Information Science. Go. Now do you have this little thing here? Okay. So now you click on here, and you just click Enroll. Okay, that work now? Anybody not able to do that? And then Submit. I guess you have to click Submit. Everybody there? Okay. All right, so now you're all enrolled. So if I send announcements, you'll get them. Okay, so now go to the class in your list of classes. So like here's, where is it? Here, this one. Information Science Lab Fall 2014, right? Everyone see that? Anybody having trouble? One. I want to make sure everybody's enrolled here. Anybody having trouble? Everyone got it right? Please let me know. Okay, so now we go here to this one. Click on that. And everyone got here? And now click on the content page. And what I did here was I imported all my stuff from last time I taught this course, so we're not going to follow all of it. So there's a whole lot of stuff here, but you don't need to do all of it. So don't worry about it unless I tell you. But you can also look at, I put it there so you're free to look at it if you want to. There's a lot of YouTube videos, but I'll probably do them again anyway, so. Okay, so everyone see this? All right, now there's an extra credit assignment here which you didn't see, so I will extend that for a week, so you'll have, you can do it through next week. Okay, but we'll talk about that later. Go all the way down to the bottom though, and do you see this? Do you see our week 1 quiz? Okay, and what happens if you click on that? You get this screen? Does everyone get it? No? Who doesn't get it? Are you enrolled? Oh, there it is. Yeah, that's it. Oh. Are you enrolled? enrolled? You're not enrolled. Okay, everyone there? So down at the bottom on contents. So anybody not there? All right, and you can begin it. Okay, so just click begin, and you can start this.
We need a password.
Oh yeah, you do need the password. Okay, is everybody ready? Anybody not ready? One. Okay, so you have 15 minutes to do this. It will automatically submit once you do it. Okay, is everybody ready? Okay, now I'm looking at anybody else's, but I tried to prevent that by the questions come up at random. So people will have different questions and you can't backtrack. So once you've answered a question, you can't go back. Okay, so it's not going to be too easy to cheat. Okay, is anybody not ready? Okay, I hope I know the password. I hope it is 1111. Does it work? Okay, so go ahead and do it. It will automatically submit everything in 15 minutes, but I don't think it'll take you that long to finish it. 1111. Okay, so one more thing here. There's an announcement. Oh, you should have gotten this announcement by email. But anyway, it says, please send information about you, your age, major, career plans, year, hobbies, programming experience, math and statistics courses, taking anything else of interest, and your photo. Please make sure you send your photo. Send it with the subject 2014 Data Mining Class Fall Bio to here. And also please note that whenever you send me email, send your photo so I know who I'm talking to. I won't respond to questions without it. Okay, just yes. Oh, what? Oh, sorry. So change this, sorry. I copied that from data mining. Send this to, change that to information science. Okay, not data mining. Okay, so I can distinguish. Okay. Any other questions? Okay. Now, information science. Okay, I keep forgetting. All right, now let's go back to the R course that you've worked on. So that's R, what was that? I'm sorry, that was Code School, right? So go back to Code School, and let's go to here. And you can sign in, I guess, if you created an account. I think I did, maybe I didn't. Okay, anyway, let's... Okay, so we're at try R. Now, you were supposed to go through 1 through 4, right? If you didn't go through 1 through 4, you're going to have trouble following along here because this course won't allow you to go ahead of where you last did. So anyway, let's go to 2. So hopefully you can at least get to 2. Hopefully you did at least you finished 1. And let's look at some of this in 2, just to review. Okay, can everybody get to, well, if you can't get to 2, you should definitely catch up by next class, and you'll just have to follow along with what we do here. Okay, so 1 plus 1 gives me, is everyone here? I'm starting at the top of expressions. Everyone there? Can you get up to there? Oh, this is 1. I don't want 1. Can I get to 2? Okay, sorry. It's not letting me go to 2. Okay, sorry. Let's go to help in 1. Okay, this is in 1. Let's go to help. And scroll and go down to here. And it says you can do example and min, and that will give you an example of this function called min. So if I click on that, instead of typing it, I do that, and it's going to give me an example of this function called min. Okay, so let's try and just, some of the documentation, the examples, a lot of stuff in R is a little hard to read. So I'd like to go through it a little bit with you so that maybe I can help you get a feeling for what it's like. Let me see if I can turn this off. Settings, tools, extensions. Okay. All right. So look at this. Min. So this means that it requires a contributed package called stats. Remember, I talked about R has a lot of stuff with that people contribute to it, and that's not part of the base package. And this is one of the packages that is a contributed package, so you would need that in order to run this min. But I think actually it's in the base, and it also requires another package called graphics. Okay, so here's an example of how it would be run. Min 5 to 1, comma pi. So what it's doing, can anybody guess what it's doing here? What's the answer that we get? 1. So how could that be? First of all, let's open up R. So let's go to here and here. And go to R, and open up this version, the later version, 3.11. It's called i386 3.11. Okay, and actually let's type that in. First let's type in 5 full colon 1. Just try that. What does that give us? 5, full colon, 1. What does that give us? The sequence of numbers 5, 4, 3, 2, 1. And by the way, what does R call this? It doesn't call it usually a sequence. It calls it a vector. Okay, so it's the vector of elements 5, 4, 3, 2, 1. Okay? All right, so that's what that gives. So, but what about this? So what is this talking about? First of all, how many arguments are there in this? Oh, by the way, so the one word, when we say we use a function, if you want to sound like you know something about programming, instead of saying you use a function, you can say you call a function. Okay? So you can say you call a function instead of use it. So how many arguments are we, when we call this function, how many arguments are we using? When we call this function? 2. How do we know that it's 2 arguments? Because what? Because there's how many commas? Just 1 comma, right? So the commas separate the arguments, right? So what's the first argument? It's that vector, right? 5, 4, 3, 2, 1. That's a single argument here. Maybe that's confusing, but that's the way it is. Now, what's PI? What do you think that might stand for? Any guess?
3.1.
Let's check and see let's try this. Type PI, see if it means anything. What do you get? So that's pi, right? PI is a keyword for pi. Okay, so how many arguments are there? 2. The first one is what kind of thing? It's a vector, and the second one is just a constant, right? All right, let's make this a little simpler call. Let's try a simpler example. Let's try min, open bracket, 5, comma, 9, and hit enter. What do you get? You get what? 5. So why is that? It's asking which is the minimum, right? Right, so which is smaller, 5? It's saying which is smaller, 5 or 9, right? Okay, everyone see that? So you get 5. Okay, now, with that in mind, what do you think is happening here? So here we have a sequence of 1 to 5, and we have pi. Which is the smallest of that sequence? 1. Right? So that's what it's doing here. Okay, let's skip, sorry. Now how about this one? What do you think this is doing? P-min. Let's type it in. Let's try that. P-M-I-N, open bracket. What did we say? 5 to 1? 5 colon 1? 5 colon 1, comma, pi. What do you think? Why is this doing this? Watch what happens. Why is it doing that?
5 minimum numbers.
What?
5 minimum numbers.
Yeah. What do you think it's doing here? Let's look at the results. What's the first result? Pi. What's the second result? Pi. What's the third result? 3. Yeah, this is a 3. What's the fourth result? 2. What's the fifth result? 1. So what do you think it's doing? It's what?
Starting at pi is the minimum and then putting out 5 numbers.
I'm sorry.
Starting at for pi is the minimum number and then
Yeah, I'm not,
badly worded.
yeah, I'm not sure what you mean exactly, but anybody else want to say it? What do you think it's doing? Somebody else? No guesses? Okay. What it's doing is, it's taking each element in the vector and doing a minimum for each one. So it's comparing 5 with pi, 4 with pi, 3 with pi, 2 with pi, and 1 with pi. So when it compares 5 and pi, which is smaller, 5 or pi? Pi, so it writes pi. When it compares 4 and pi, which is smaller? Pi. When it compares 3 and pi, though, which is smaller? 3. When it does 2 and pi, 1 and pi, right? This is very typical of the way R works. In fact, let's try something like this. Take, can we do this? Try this, x, and then arrow, like that, and do, again, 5, 1. Okay, now hit X after you do that. What happens when you hit X? So X, arrow, 5, 1, 5 colon, full colon 1. Right? What happens when you hit X now? If I type X, what happens? I get that vector, right? Because I stored that vector into X, right? Everyone understand? All right, now try this. Or tell me, can anybody make a guess as to what would happen if I wrote X plus 1? If I type X plus 1, can anybody guess what's going to happen? What do you think?
From 6 to 2?
Yeah, from 6 to 2. Let's test it. X plus 2. And hit enter. I'm sorry, I said X plus 2, but anyway. X plus 2, right? Or X plus 1, whatever, right? Is that clear? What happened? Okay, how about if you do X times 4? What's it going to do? It's going to multiply each element of the vector by 4. Right? You understand? Okay, now try type Y, full colon, arrow, and let's make another vector. Let's say 10 to 6. 10 down to 6. So Y is the vector from 10 down to 6. Okay, everyone understand that? Okay, so check out Y. What's Y equal to? Right? Okay, now what's going to happen if I add X plus Y? I tried X plus 2 and I saw what I got, right? I tried X plus 2. What did I get when I did X plus 2? It just added 2 to each element, right? Now, if I try X plus Y, can you make a guess? What do you think it's going to do? Any guesses before you do it? What? It's going to add them element by element, right? Okay, let's check it. X plus Y. Did it work? Okay. How about X times Y? What does that do? Oops. X times Y. What does that do? Okay, it multiplies them element by element, right? How about this? X. No, I don't want to do that. Let's try Y. How do you raise it to a power? Suppose I want to square every element in Y. How do I do that? What's the keystroke for that? That. Caret, which is, where's the caret? It's above the 6, right? Above the 6 on your keyboard. So let's write that and see what we get. Okay? So what did it do? It squared each element. Everyone get that? Everyone follow that? Okay, how about if I did x caret y, I'm sorry, y caret x? What's that going to do? Let's try it. Y caret x. What's that going to do? So what's the first element? It's 100,000. Where's that come from?
10 to 6.
What was y again? 10. And what was the first, I'm sorry, what was the first element of y? 10. And what was the first element of x? 5. So what's that? 10 to the 5th power, right? And so on. Okay? So it does it like vector by, it treats vectors like, sort of works on them piece by piece, element by element. Now here's something weird that it does, which you sort of have to get used to, I guess. And that is, let's make another vector, which is just the numbers 1 and 2. So just a sequence, let's say, from 1 to 2. So like this. Let's call it z. And let's go from 1, full colon, 2, like that. Okay, everyone get that? So let's check what z is. So that's z, right? 1, 2. Okay, now, what experiment could we try now? What? Let's try adding. What experiment could we try now in terms of adding? Any experiment you want to try in terms of adding? Okay, let's add x and z, but before we do it, I don't think you might not be able to guess, but what do you think you might get if you add x plus z? It doesn't quite make sense, right? What do I mean by it doesn't quite make sense to add x and z?
Elements are less than x.
Yeah, because z only has 2 elements, so what's it going to do, right? It's not clear, right? There's no correct answer. It's just the decision, what the programmers that made R, what they decided to do in this case. So any guesses what they might have decided to do? They call it, they recycle the vector z. What is that? What do you think they mean by recycle it?
So just use 0 for each.
Yeah, you could, that would be a natural thing, but that's not what they do. They do, well, let's try it and see if you can guess what they did. X plus z. So it gives a warning, but that doesn't mean it didn't perform it. So there's a difference in R between warnings and errors. Okay, errors don't complete. Warnings are just a warning. Okay, but it doesn't mean it didn't do it. So you can even ignore the warning, but it does say, in x plus z, longer object length is not a multiple of the shorter object length. What was the longer object in this computation? X. What was the shorter object in this computation? Z, right? What was the length of x? 5 means how many elements were in x. What was the length of z? 2. In fact, let's just check that before we do anything else. I think it's length x. Okay? You can do length x and you get 5, right? That's the length of x. Length of z is 2, right? Okay, but anyway, so which was the longer vector? X, and z was the shorter. X had how many? 5, z had 2. So it says, now what does it say about that? Not just the one is longer than the other, but something more specific than that. What does it say? It's not a multiple. What does that mean? 5 is not a multiple of 2, right? Okay, so that's what it said, and you might say, well, who cares? Why did it say that? But anyway, what did it actually do, though? What computation did it perform? So here's the computation for x plus z. What did it do?
Just use first elements.
Add two.
So it added what? What was where did the first element, where does this 6 come from? It came from x, which was, I lost my x here, but x was 5, and z was 1, so 5 plus 1 is 6. Where's the second 6 come from? The second element of x was what? 4, and the second element of z was 2, so that's where that comes from, right? Then where's the third element come from? This is when the recycling happens. What was the third element of x? 3, 5, 4, 3, right? And what was there is no third element in z, right? So what does it do? It recycles. What does that mean? Goes back to the first element of z and adds it. So what do we get? 3 plus 1, we get 4. Okay, and then we get 2 plus 2 is also 4, and so on. Okay? So that's called recycling in R. Now, I don't know any other language that does that. It's kind of a weird thing, but that's what they chose to do. So you just have to be aware that that's what happens. Okay? Everyone get it? Actually, MATLAB is kind of similar to R. That might do it. I don't know. I don't know MATLAB actually. Okay, does everyone get this? Everyone following along? Okay, let's go back to this. So, what did it do here? P-min is a special form of the minimum, which does what? It takes this whole vector, 5, 4, 3, 2, 1, and does what? Compares it element by element with pi, and reports back a vector for the answer. Okay, is this clear? Okay, so now try bringing up help for the REP. By the way, if you've already done something, you can click here, and it allows you to access it again. So if I click here, it allows me to access it again. Or maybe it even makes me access it again. Okay? So if you already went further than this, you can go back and do that. Okay, now try bringing up help for the REP function. So how do I do that? How do you get help for a function? HELP, open bracket, REP, close bracket. Okay? And it brings up the help. And as I told you before, it's not so easy to read it. In fact, let's try it in R again. So try that REP help. I'm sorry, help REP. Okay? So does that look easy to understand? Description. REP replicates values in X. It is a generic function, and the internal default method is described here. Okay, so a generic function, we don't know what that means, but it's just a special type of function in R, but you can just ignore it if you don't know what it means. It doesn't matter. It's for people who do know what it means. It's useful to know that it's generic, but you don't know what generic means, so it doesn't hurt if you don't know. Okay, rep.int and rep_len are faster and simplified versions for two common cases, and they are not generic. Okay, again, we don't know what that means. Okay, so it tells us how to use it. So it says rep x, and then it gives us a different version, rep int, and another version here. But we're just talking about rep. Okay? And it says x. So what now, down here, it tells you what these arguments are supposed to be. So, for example, I don't know what this is supposed to be, what times is supposed to be. So I can look it up here to see what it's supposed to be. Okay, but here, even this, I don't know what x is supposed to be. Okay, so I can look it up. Here's x. So what does it say about x? What can x be? A vector. Okay? Is everybody following me? Am I losing people? Anybody getting lost here? Okay. So it's a vector. Now, what's a vector? What is a vector? We've been using vectors, right? We know what they are. But one thing to know is that a vector can be just a single element. It's still called a vector. Okay, so if you just have a constant like 8, that's still called a vector, actually. It's called a vector of length what? Of length 1, right? So, okay, so it's still called a vector, though, okay? So that's what they said. So, so x can be a vector of any mode, including a list. Now, we don't know what a list is yet, and we don't even know what they mean by mode. Okay, so we'll ignore that for now. It can also be a factor. We don't know what that is. It can also be these things, but we don't know what they are. Those are dates, but forget it. And it's all confusing because we don't know 95% of what it's talking about here. Okay? And then, down below, they give some details about it. For example, here's the default behavior is as if the call was this. What do they mean by the default behavior? What does that mean, default behavior? That means if you don't set anything special, then this is what will happen. What do they mean by, but okay, so this is still very confusing, because first of all, how many arguments are there here? They're using this function called rep, and how many arguments are there? 4, because how many commas are there? 1, 2, 3 commas, right? So there's 4 arguments, and we don't know what in the world they are, right? Well, we know the first one. What's the first one? That's the vector, right? But the rest, we don't know what they're talking about. Okay? Now, what do you think rep stands for? Any guesses? Repetition. Okay, it's repetition. So if it's repetition, then you can probably guess what this stands for. It's how many times you're going to repeat it, right? And you can verify that here. Times is what? It's an integer now that actually can be more than an integer, it can be a vector, which sounds really weird. But you know, they're trying to be general here. So, in other words, yeah, in the basic use, we'll just have it as an integer, but then they said, oh, well, let's expand it to somehow be something more than that. But in the simplest case, it's just an integer. Okay? So let's try it out in ours here. So try and see if you can make it work for something. So you want to type in REP, open bracket, and use just 1 comma, and you decide what you're going to put in there and see if you can guess what it's going to do before you put it in there. I mean, before you run it. So put something in the comma. Oh, by the way, this is a weird thing about, you can't, you know, I can't move the pointer just by clicking in this interface. Like I want to put something in here, I can't do it. Okay, how do I have to move? I have to use the arrow, the left arrow, 1, 2, and type. Okay, I hate that about R, but that's the way it works. Okay, so put something in, but before you run it, make a guess as to what it's going to do. So let me put in 4, and then put in 3 here. What do you think it's going to do? Any guesses? So 4 is what? Is the first argument, that's the x element, and 3, I believe, is the times element. So what do you think it's going to do? Right. It's going to do that, right? Does everyone get it? Okay? And so on. Any questions about this? Okay, now some of you are getting bored. But I'm trying to go through this so that you, when you do it on your own, you're not going to be too confused. Okay, so I'm going through it in detail today. Okay, let's play around with it just a little bit more. Let's try this one. Hit the up arrow key, and you get you don't have to type it, right? You hit the up arrow key, and then change this to this. Okay, you see what it did? Or change it, let's try it one more time. Change it to this. That. Okay? And you get that. Okay? Everyone see? So it'll repeat strings as well. Now how about if I wrote this one without the quotes? So it'll write 1, 2, 1, 2, 1, 2, right? Not add them, just write it, right? Okay, so because Z is 1, 2, right? Let's see if it works. Okay, does that work? Any questions so far? So this is called the rep function, and we pulled up the help on it, and we see that x doesn't have to be a single number, right? We saw x could be a string, and x can even be a vector, right? Like 1, 2, right? 1, 2, 1, 2, 1, 2. And the second argument is times, which tells you how many times to repeat it. Now what did it say again? It said about usage, it said the default behavior is as if the call was this. Let's try one more. Let's try just rep Z. What happens? R-E-P Z, just Z, no times in there. What do you get? Rep Z. You just get Z, right? Right, you just get 1, 2. So what do they mean by the default behavior is? Well, we just did it with no arguments except for the first one, except for Z, right? So if you don't fill in any of the arguments, the default arguments will be here. The default arguments will be here. So time will be set to what? I'm sorry, times will be set to what? 1 by default. And then these, we don't even know what they mean. And this one, we don't know what they mean. Okay? All right? Everyone get it by what they mean by the default behavior? The default behavior, if you don't fill in things, then the default takes over. Okay, does that make sense? And then they say normally just one of the additional arguments is specified, but if each is specified here, with either, anyway, blah, blah, blah. And then value. What does value mean? Value is what, okay, if you remember the definition of a function in mathematics, like this one, right, the square root of x, if you remember that. So we say, f of 4 is what? Square root of 4, right, which is what? 2. So we call 4 the input to the function. That's what we're putting into the function. And we call 2 what? Not the input, but the output, right? So functions always have an input and an output, right? Right, so let's take another function. So f of 3 is what? 9 plus 5, right? It's 14, right? So the input is what? 3, and the output is what? 14, right? Okay, so functions always have an input and an output. And what they use, the word they use for the output is value. So value here means the output of the function. So what function are we doing? Repeat, rep, right? So what kind of output did we get when we did it? Well, what did I get there? For example, I did rep z3 here. Or sorry, I did rep APU3. What did I get? What do you, or let's do the one with rep Z. Oh, that's still not the right one. Let's do that. Rep 4.3, what did I get? 4.4.4, what kind of thing is that? Is that a function? No, it's not a function. It's a vector, right? 4.4.4 is a vector, right? Agreed? So what comes out of this function? A vector. How about this case? Was this still a vector? Yeah, it is a vector, actually. It's a vector of 3 strings. So vectors don't have to be numbers. They can also be strings. Okay, we still call it a vector. Okay, so it's a vector, it has 3 elements in it. Okay, so what came out of rep this one? Rep string z, 3. A vector, right? Z, Z, Z. What came out of rep APU, 3? A vector, right? So what comes out of rep? A vector. So they say, so the value refers to what comes out of it. Now they say here, what comes out of it is an object of the same type as x. Now the type of x, in all the cases we've used, is vector, right? 4 is actually a vector. The string z is actually a vector, okay? So what comes out is another vector. It doesn't mean the length is the same, because the input vector for rep here, what was the length of this one here? 4 is just a single number, right? So the length of it is what? Just 1, right? So the lengths are not going to be the same, what goes in and what comes out. But the type is the same. They're both vectors. Okay, does this make sense? Okay? So it's not so easy, as I said, to read this help, unfortunately. Okay? And then they say, these refer to different versions of this rep function, sort of specific versions, and these are apparently faster than the rep. Now we can't notice that this rep function is slow, but if we did it with a huge data set and we wanted to repeat it like a billion times, it could conceivably be quite slow. Okay, so we might be able to use one of these functions instead, which might speed it up. Okay, but we don't have to worry about that. Okay, and finally down here, they have what? Oh, by the way, they have references. So this is like where you could read about it, but I've never done that. Okay. And then finally here you have what? Examples. Oh, they also have C also. These are kind of related functions, which are similar. So you could look at the help for these as well. But here's examples. So you can just copy the example and run it. But before you run it, guess what it's going to do. This one. What do you think it's going to do? So what's the 1:4? It's the vector 1, 2, 3, 4. And what's the times argument here? 2. So what do you think it's going to do? It's going to repeat 1, 2, 3, 4 twice. So let's see if it works. Okay? So it worked. Okay, you want to try another example? Maybe a more complicated one? I don't know what this each means, actually, I forget. That's the thing about R's, it's very easy to forget. But each equals 2. They do explain it here somewhere. In here, the arguments, what is each? Non-negative integer, each element of x is... Okay, let's try this one. So, let's try this one, see the difference. So what happened there? So it repeats it twice, but each one is doubled, is repeated, what do we say, element by element. Okay? Everyone get it? Okay. Now let's continue with here. Okay, so here's the help for rep, and it says the package is base, so it comes from the base package. It means you don't have to download anything special. And replicate elements of vectors and lists. We don't know what a list is, but we have an idea now of what a vector is. Replicates the values in X. It is a generic function, and the okay, so we don't understand all that? Okay, any questions so far? Okay, let's go on to let's go on to files. Okay, typing commands, each time you need them. So just using the command line like this only works for short scripts. So you don't want to have to type like 100 lines. Of course, our commands can also be written in plain text files with a .r extension by convention for executing later. You can run them directly from the command line or from within a running R instance. We stored a couple sample scripts for you. You can list the files in the current directory from within R by calling list files, the list files function. Try it now. So let's click on here, list files. And so what this means is that in there, actually R is installed on their server, and they're connecting to their server through this web page. That's how it's running. Okay? So in their server, in the location where R is stored, they have apparently 2 files there. One is called bottle1.r, and one is called bottle2.r. Okay, now let's try this on our installations of R, but before you do it, let's try and find out where our function is, where R is located. So let's go try and find it. So how can we find it? We can go to, I guess, where? Not recent places. I guess we have to go to local disk and program files and scroll down and look for R. And we have actually 2 versions of R installed here. And where is it? Here? Oh, here it is, in bin. It's in bin, B-I-N. Okay? Does everyone find it? You can see R is stored here, r.exe. Okay? All right, now let's try that on our, this thing, list files, on our installation, see what happens. What is that? It's weird. It looks like it must be stored here. So I'm not sure why this is doing this. Must be a weird kind of installation that they did here at APU. So, all right, let me try one more thing. Oh, I'm sorry, okay. So it's not where R is stored. It's in your, what's called your working directory. Okay? And our working directory, if you type this, get WD, open bracket, close bracket, you try that, type that yourself. Get WD, where is it? It's in documents. Okay? So I made a mistake. It's not where R is stored, it's your working directory. Okay? So if we put a file in there, we might be able to read that file. So let's do something. Let's go back to our interface here and go to File and Save History up here, up at the top. File, Save History. Okay? And let's just click Save. Now you can see that it's saving it in our working directory, right? It's going to save it in our working directory, which is Documents. Okay, so click Save. Oh, it says, do you want to replace it? Yeah, let's do it. Well, no, let's not. If you did it already, it doesn't matter, but let's call it one.history. Just for whatever reason. Okay, and do that. Now check and see if that's actually in your working directory. Is it there? Now how do you open that to read it? How can I see what that looks like? I want to know what's inside it. How can I do it? Open it in what? Notepad? How about another program? Notepad++. And that's in the so-called context menu. In other words, if you right-click on this, you'll see that Edit with Notepad++ is there. So try that. And you can download Notepad++ yourself. Okay? And what does it have? It has a list of all the commands that I typed, right, in the current session. Now suppose that I just want to do I need Z. So suppose that I do this. I get rid of this. So all I want to do is have a definition of Z, and then I'm going to get rid of these and get rid of everything up here. I think this shouldn't be a problem. So I just want to make sure that I have a definition of Z there, and then all this other stuff. Okay, like that. And then I'm going to rename this as 1.r. So save this as 1.r. 1.R. Okay, 1.R. Okay, I just want to make sure that this makes sense. If I didn't define Z, then all these aren't going to really make sense. Although actually they're already there, so it's okay. Okay, anyway, let's click Save. Okay? Does that work for everybody? Okay, now type, what was the command again that we just did? List.files. Oh, I already have it there. So I'll just hit the enter key twice, the up key twice, like that. And what should we see now? We should see these two files as well, right? One.rhistory and one.r, because we just put those in there. Okay? Any questions about that? Okay, now let's go to see what they say next. So list.files is a function, and which shows what's in the working directory. Okay, now to run a script, pass a string with its name to the source function. Okay, so they have a script in their directory called what? Bottle1.r, and if you want to run that script, if you want to run all the commands that are in there, you just type source, and you need the quotation marks around the name. So let's see if we run it. We don't know what's in that script, but we can find out by doing that. Okay? All right, now let's try running our one.r script. Okay, in on our R console. So, how do we do it? How do we run the one.r? What's the command? Source. And what else do you have to not forget? Open brackets and quotation marks. Okay, like that. Everyone get it? And if you hit enter, nothing happened. Why not? That shouldn't be right. Why? No, that's not right. Why? Oh, there's some setting here. I think. Should run that, but okay, I'm not sure that doesn't work actually. It should work. It's not outputting it. It read it, but it didn't output it. So like if I had in here, if I had defined another variable called k, let's see if this works. Okay, so I just did k is 1 to 19, right? Let's see if this works. Now, I don't have k defined yet, right? It's only in this script. I haven't entered it into R yet, right? Let's see if when I do it, when I do this again, I'll repeat this, I'll read it again. Now, if I type k, what happens? Yeah. So, it did read it, but it's just not outputting it for some reason. I'm not sure. There's some setting, some option that you have to set to get it to output, and it doesn't, I don't remember what it is. Okay, does everyone follow what we're doing though? Okay, do you see what I just did with k? I put k, I defined a variable called k up here from 1 to 19, and then I read this whole file just to try and prove to you that it's actually reading it. And to prove to you that it actually read it, I typed k and it did print out what I defined in the source file. Okay, but I don't know why it's not outputting it. So I'll have to figure that out. So if somebody wants to figure that out, that would be great. I'll have to try to do it. Okay, here, now try running bottle2.r. Try that. Wrong. So what do you have to do to get it, to run it? What do you have to type? Remember that bottle2.r is located on their server in their workspace. It's called the workspace. The working directory is called the workspace. So, okay, so that must be in there. Okay, chapter 1 we completed, okay? Everyone following so far? Okay, let's go to chapter 2. Vectors. Okay, let's click continue. Okay, a vector's values can be numbers, strings, logical values, or any other type, as long as they are all the, what's this say? As long as they all what? Are the same type. So first of all, what are the types that they mention here? What are the types that they mention? Numbers, strings. Did we talk about logical values last time? What are logical values? Logical values means true or false. Okay? So true or false. And the way that you type true, you don't use it, it's not a string. So you don't use quote true, you just type the letters T-R-U-E, and they have to be capitalized. Okay, so anyway, a vector can be composed of numbers, or it can be composed of strings, or even logical values, and so on. But what's the caveat here? It has to be all of the same type. So you can't have, in a vector, you can't have numbers and strings together. Okay, you understand? In fact, let's try and do that. Oh, sorry. So here's how you create a vector. We've used a special way to create vectors, but it was very limited. Right? What do I mean by limited? Why do I call the way that we used very limited in the way we could create vectors? What way did we create vectors? How have we been creating vectors? Just 1, 2, 3, 4, 5, 6, right? So that's, you can't do like 1, 8, 12, 24, right? You can only do 1, 2, 3, 4. That only a sequence, right? That's very limited. we also used actually another way to create vectors, which was the rep function. That actually creates a vector also, but that's still pretty limited. It has to be something repeated over and over again. Okay, the general way to create a vector is to use this C function. It's called the combine function, or it's called the concatenation function. It's another word for combine. So this is going to create a vector with the elements 4, 7, and 9. Okay, so you can try it. Okay? So that's much more flexible than what we had so far. Okay? The C function is short for combine, creates a new vector by combining a list of values. Now create a vector with strings. Now, I guess in the C function, I forgot, but I guess in the C function you can use single quotes. Okay? So if you do that, now you get that. Okay? Everyone understand? Okay, vectors cannot hold values with different types. They call it modes in R. Different types. So what do we mean again by different types? Numbers versus strings versus logical and so on. You can't do that. Well, you can, but it won't do exactly what you think. So what types do we have here? What's the first one? It's a number, right? What's the second one? It's called a logical value. And what's the third one? It's called a string. So you might think, oh, I'm going to get a number and a logical value and a string back. But that's not what you get when you do this. If you try it, you'll see it does that. So it converts everything to string. So whenever you have a string in there, everything will be converted to a string. Okay? So you have to be careful about that. All the values were converted to a single mode, characters, so that the vector can hold them all, because a vector can only hold one type. Now that's very inconvenient for data mining. Why? Because in data mining, you're looking at lots of different variables, like for example, people's height and their weight and their favorite beer. Okay, but favorite beer is not the same as weight. Right? Favorite beer is going to be a string maybe, or something like that. And weight is a number. So it means you couldn't put all of that in one vector. So it's very inconvenient for data mining in general, but it's also useful for certain parts of data mining. Okay. All right, so we have to stop here. So I think I asked you to finish through chapter 4 last time. So I'll give you a repeat. So I'll do this. What's that going to do? Okay, so I'll give you a repeat. To do last week's homework again for this week. Okay, you get a grace period of 1 week because you're just getting started. Okay, so I want you to finish and you'll have a quiz through chapter... Maybe I should make it. Let me see this. Let's say through chapter 3. Okay? So you'll have a quiz up through chapter 3 next week. Okay? At the beginning of class. All right? So you have to go through it, learn it, and memorize it. Right? You have to memorize the commands. Okay? So you have 1 through 3. You need to know by next week. Any questions about that? Okay, so we'll go a little slow at the beginning, so you can get. Now, don't forget, how do you install R? Very quickly, you type in up here R, that might be enough. Where R and CRAN, here it is, R, at least on my computer. But you might have to type this, R programming or something like that. So R programming would also work. Anyway, you want to get to this, the r-project.org. You go to here, go to download R. Remember we tried this last time and it took too long. Go somewhere. And you do it for your operating system. And you just need the base, which you can click over here to get. And then download for Windows. And then if it doesn't take forever, which usually, I mean, on my computer at home it just happens immediately. But here at AP something's wrong. But anyway, you can just install it and then you'll end up, after you finish the installation, you'll have something just like this. Okay? Alright? And then don't forget, we haven't talked a lot about it, but you can save your history. So what you can do is when you end, you can go File and Save History. And now what you eventually want to do is you're going to have different projects. You want to save the histories for different projects separately. But for now you can just do Save History. And what that will do is the next time you open up R, you'll have that whole history available for you. Okay, so that's kind of useful. And also Save Workspace. What that does is anything that you created, any variables that you created, will then be already created for you. That could be a good thing or a bad thing. If you created a lot of stuff, it could take a long time to open it up because it has to build it all up again. And also, it might use up memory. It might slow your computer down. But in our case, it's not going to happen. We're not going to be working with such big data. Okay? So anyway, you can save your workspace, so that will save all the variables that you created, and you can use them next time. Okay? So you can do that. And we'll talk about how to manage different workspaces, different projects, because that's really useful. Okay, don't forget that you have two things to do besides prepare for the test, and that is on Blackboard. You should send me this, self-description, okay? And you should, if you want to, there's an extra credit assignment here somewhere, here, which you can do. I'll change the due date to, in fact, I'll do it right now, to, how do I do that? Oh, that's the announcement. So it's in here. I'll change the date to next week, which is what? Oh, sorry, due date here to the 15th, to the 22nd. Okay, if you want to, you can check this out. There's a video that I made that describes what you're supposed to do. Okay, it has to do with data mining. It has to do with the kind of data mining that I do, which is about Twitter. So it has to do with that. So if you want to do that, it counts as a full extra assignment. So you can do it if you want to, but it's not mandatory. It's just extra credit. Okay? Any questions? Okay, that's all. And I'll try to post this video. And my videos are located, if you want to look for them, if you look for YouTube. There you go. It's called this. This is, if you look for this user, yes to that, you'll find my videos. Yes to that, yes to that. And if you search through there, you'll find videos that I posted. Okay, so you can check them. Okay, so I'll try to post this video, today's class, up there, so you might be able to, if you need to refer back to it. Okay, any questions? Okay, that's all. Yeah.
Yeah, I was trying to do the homework of coding school.
Yeah.
Yeah, I was like there's a problem.